Hello, and welcome to our course on Descriptive Data Analysis, or DDA. DDA is the area responsible for characterizing and summarizing data. It usually comes before we apply the inferential methods that are capable of extrapolating from data. This course starts by presenting the concepts of data distributions, and then we go into the many summary measures, including central tendency measures, variability measures, relative position measures, and measures of shape. We also talk a little bit about the normal distribution, which is very important from a practical standpoint. Then we present association measures and linear regression. This is the structure of our course. We start with an introduction to descriptive data analysis, then we talk about data distributions, and we go into the summary measures, starting with the central tendency measures, then variability measures or measures of dispersion, then relative position measures, measures of shape, then we talk about the normal distribution, main association measures, and we conclude our course with linear regression. In terms of classes, we have 7 classes planned for this course. This is the sequence of the classes. For the summary measures, we are going to have 1 class for each of them, and then 1 last class talking about the normal distribution, association measures, and linear regression. Starting with our first class, before we discuss descriptive data analysis specifically, I want to review with you the data science workflow. I divided the data science workflow in 5 main steps. If you search the literature, you may find different ways of organizing the data science workflow, but this organization here, I designed to serve the purposes of the courses that we have here in our channel. The first step in the workflow is the analytical mapping. This is the moment when we go deep into the business problem so that we try to understand what is the business about, how its performance is measured, and also what are the requirements for the solution that we are going to devise, some use cases, and it's very important to understand how we can apply any data science or any descriptive data analysis to the data available. The second step involves collecting data or retrieving information, selecting the data that you're going to use in your analysis, and also preparing the data for analysis. The third step is data analysis, and the fourth step is data analytics. I make a difference between data analysis and data analytics in the sense that data analysis is more related with descriptive data analysis and data visualization, and data analytics is related with extrapolating the information available in the data by inferring something from data. So here in step 4, we are talking about generalization or generalizing the data that we have. Whilst here, we are basically interested in describing and understanding the data that we have. And so this is an important difference between these 2 steps. Data analytics involves machine learning, deep learning involves inference, as I said, whilst data analysis doesn't involve any of these more sophisticated techniques. After we go through these 4 steps, we have the 5th and last step in the data science workflow, and this is related with validating the solution that you proposed and integrating it with your customer system. Another important aspect that I want to stress in this workflow is that we have this bar here at the bottom, and we have this double arrow in all boxes or in all stages of the workflow. This means that I can come from the last stage back to previous one, or back to the third one, or back to the second, or even back to the first. This means that after I get my result, I can conclude that I need to do another business analysis because something was missing or something wasn't good enough. I may realize that I can apply a different data science technique to my problem, and then I have to go over all these steps again. This is very important because it shows us that this workflow is iterative and interactive. Interactive in the sense that you can interact among the steps, and iterative in the sense that you can go from any stage that you are or any step that you are here back to a different one, or forward to a different one that is not its next or previous step. Having said that, we can now discuss what is descriptive data analysis, or DDA. As I mentioned in the introduction, this is basically the process of summarizing, organizing, and characterizing the data so that it can be more easily described and understood. Also, the difference between data analysis and data analytics is that data analytics is concerned with inferring something from the data. This means getting a result or getting an information or getting a knowledge that is not directly available in the data, but it has to be extrapolated from the data. And this is related with the concept that we call in machine learning generalization. Another way of understanding DDA is by looking at some of the questions that it tries to answer. The first question that I posed here is related with how are the variables distributed. Determining the distribution of a variable corresponds to calculating the frequency of occurrence of each value of the variable. Or, in a different way, you can calculate the frequency of occurrence of each category of values of the variable, category or interval of values of the variable. The second question is related with the typical values of each variable. In this case, we are looking for a value that represents the variable. This is considered the typical value. This is usually associated with an average or with any type of mean value of the variable. The third question that we detach here is related with the dispersion or variability of each variable. The goal here is to measure the spread of the variable. Fourth question talks about the shape of the distribution of the variable. The shape of the distribution of a variable is very important because it allows us to spot outliers, to observe the accumulation of the variable over the axis. It also allows us to observe the skewness and the spread of the variable. And finally, what are the types and levels of association that we have among variables? This is also important because it allows us to observe if the variables are associated, what's the strength of this association, and what's the direction of the association. For example, two variables may be positively associated or negatively associated. In summary, we have three main types of descriptive data analysis. We have frequency distributions, we have the summary measures, and we have the measures of association. Frequency distributions, as I mentioned in the previous slide, it aims at finding the distribution of each variable. The summary measures, they include central tendency measures, variability measures, and measures of form. They are basically numerical synthesis of the data. And finally, the measures of association aim at finding the association. For example, if there is a correlation between the variables, and they can be applied to two or more variables. This organogram gives us an idea of what we are going to study here in descriptive analysis. We will start with frequency distributions, then we'll go into the summary measures, central tendency, variability, and form, and finally, we will study the measures of association, more specific, covariance, and correlation. Thank you for watching and see you in our next class.